Welcome to This Explainer. Today, we're completely stripping away the sci-fi hype to unpack exactly what artificial intelligence is, how it actually works, and most importantly, what it means for our future. We hear the term AI literally everywhere these days, from the daily news to our own workplaces. But honestly, getting past all those buzzwords and understanding the actual mechanics under the hood is absolutely essential for navigating the modern world. So let's get into it. Way back in the 1960s, AI pioneer Marvin Minsky boldly predicted that creating artificial intelligence would be substantially solved within a single generation. Obviously, that was a bit optimistic. As history has shown us, this whole endeavor has proven vastly more difficult than those early pioneers ever could have imagined. Getting to the incredibly powerful tools we use today, well, it's been a wild ride full of massive ambitions and, honestly, some incredibly frustrating roadblocks. To make sense of this massive topic, we're going to follow a simple roadmap. We'll define artificial intelligence, take a quick look at its roller coaster history, figure out how AI actually learns, see how it's operating in the real world, and finally tackle the ethical minefield.
All right, Section 1, Defining Artificial Intelligence. Let's set a baseline and figure out what this actually is once you strip away the Hollywood tropes. Here is the absolutely crucial thing to remember. AI isn't about human sentience. We're not talking about a machine possessing a mind like you or I have. Rather, it's just an engineered agent trying its absolute hardest to execute a specific goal. It perceives its environment, processes that information, and takes actions to maximize its chances of achieving exactly what we programmed it to do. So it's all about optimizing an outcome, not replicating human consciousness.
And that brings us to a huge divide in the field: narrow AI versus artificial general intelligence. Look, literally everything we use today, from your smartphone's facial recognition all the way up to those massive super smart chatbots, that's all narrow AI. They're highly specialized to do one thing really well. But artificial general intelligence, or AGI, that is the ultimate dream. Tech giants are pouring billions into this right now. We're talking about an AI that possesses the breadth and versatility to complete virtually any cognitive task at least as well as a human mind can. Now, we aren't there yet, not even close, but that's the finish line everyone is sprinting towards. Moving right along to Section 2, a roller coaster history. How exactly did we get to this point? The quest to build these systems is literally decades old. Alan Turing set the theoretical stage back in 1950, and the field itself was officially founded at a Dartmouth workshop in 1956. But, progress wasn't just a straight rocket ship to the moon. When all those big early promises failed to materialize, the entire field suffered through these long, brutal stretches known as AI winters. We're talking about eras starting in the 70s, where funding totally dried up and the scientific community just kind of lost faith. But then, the field explosively roared back to life in the last decade. And what's super fascinating about that huge breakthrough around 2012 is that the sudden massive success of deep learning wasn't actually driven by new math. The theories had already been sitting around for decades. It simply took us finally having enough raw computing power, specifically through super fast GPU chips and massive internet-scale datasets, to make those old ideas actually work in practice. Which brings us to Section 3, how AI actually learns. Let's pop the hood and see what's going on. So for the first few decades of AI research, scientists really leaned into symbolic AI. This was a very top-down approach. Programmers tried to feed computers strict logical rules for literally every possible situation. But, well, you and I both know the real world is way too messy for that, right? We don't think in strict logical rules. So researchers eventually shifted gears to machine learning. This is a bottom-up approach. Instead of hand-coding the rules, you just feed the machine tons and tons of data, and it identifies the hidden patterns and structures completely on its own. And that paves the way for deep learning. This is the absolute powerhouse engine driving today's AI boom. It works by passing data through networks of interconnected nodes that are loosely inspired by the structure of a biological brain. These nodes are stacked up in multiple hidden layers, and as data passes through them, the network extracts increasingly complex patterns without us having to hold its hand. For instance, the lowest layers might just pick up on simple lines and edges, but by the time the data hits the highest layers, the system can actually recognize a human face or grasp the complex syntax of a language. It's pretty wild. Now, if you've ever played around with a generative pre-trained transformer, yep, that's what the GPT in ChatGPT actually stands for, it basically follows three main steps. First, it pre-trains by ingesting a truly massive corpus of text from the internet. Then it builds its whole understanding of language simply by continually predicting the very next word or token in a sentence, over and over and over. Finally, researchers refine the model using direct human feedback to make it more conversational and, ideally, more truthful. It sounds super simple, right? Just guessing the next word. But when you do it at this massive scale, it creates systems that are startlingly capable.
All right, moving to section 4, AI in the real world. Let's look at how these mechanics are actually playing out right now.
Make no mistake, AI is completely reshaping almost every major industry. In medicine, systems like AlphaFold 2 are mapping complex 3D protein structures in just hours. That used to take months, sometimes even years. Elsewhere, researchers are using AI to predict Parkinson's disease treatments 10 times faster and significantly cheaper. But it's not all just healthcare. Militaries are deploying advanced algorithms right now to coordinate battlefield sensors and identify targets. And of course, chatbots are totally disrupting white-collar work across the board, from writing software code to overhauling customer service. Just to put into perspective how incredibly fast this is hitting the economy, in 2022, there were an estimated 800,000 AI-related job openings in the US alone. That is a massive number. Economists are pointing out that we are completely in uncharted territory here. Yes, lots of new jobs are being created, but automation is no longer just a blue-collar factory floor issue. It is now directly impacting middle-class white-collar professions, and that's creating massive, sudden shifts in our modern workforce. But of course, all of this explosive growth brings us to Section 5, the ethical minefield. These are the big, heavy questions we have to face. First off, the sheer physical footprint of this technology is absolutely staggering. By 2030, an estimated $2.7 trillion will be poured into AI infrastructure. And these massive data centers, they demand so much electricity that tech giants are literally paying to restart dormant nuclear power plants. It's true, Microsoft actually just struck a deal to reboot the 3 Mile Island facility just to feed its AI operations. The environmental impact here and the massive strain on our electrical grids is rapidly becoming a huge global concern. And beyond the environmental footprint, we're facing some serious systemic dilemmas. Because of how deep learning works, we have what's called a black box problem. That means sometimes even the creators themselves have zero transparency into how the AI actually made a specific decision. And that naturally leads to algorithmic bias. Take the Compass system, for instance, which was used in US courts. It mathematically overestimated reoffense rates for minorities simply because the AI trained itself on historical data that was already biased by humans. Throw in hyper-realistic deepfakes driving massive misinformation campaigns, plus the huge wave of copyright lawsuits from creators whose data was scraped without permission, and well, you've got a perfect storm. Which brings us to the ultimate stakes. The real existential risk here isn't necessarily some sci-fi robot uprising. As AI pioneer Geoffrey Hinton warns, the true danger might simply be an AI's superhuman ability to persuasively manipulate the public using nothing but language. Think about it. If a system learns exactly what keeps us glued to our screens, which, let's be honest, is often outrage and conspiracy, it could completely undermine trust in our institutions simply by feeding us hyper-targeted, relentlessly persuasive misinformation. So, let's leave you with this final critical thought for this explainer. As we race toward a future of superintelligence, the absolute greatest challenge isn't just going to be building the machine or crunching the data. If an AI is built simply as an agent trying to ruthlessly maximize a specific goal, how do we ensure the goals we give it are fundamentally aligned with human survival? Whose values will it ultimately hold? Because getting the code right is one thing, but getting that alignment right, that literally changes everything. Thanks for exploring this with us.